Let's begin. Today's January 10th, 2025, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 5 criteria cards. Criteria cards 8, 14, 18, 19, and 20. And the puzzle uses the purple verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 5 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, and finally criteria card E. Criteria card A takes a look at our 3-digit solution, and the Turing machine will let us know how many ones there are. Are there no ones? Is there a single one? Perhaps 2, maybe even all 3 are 1. Criteria card B will take a look at our 3 digits, triangle, square, and circle, and the Turing machine will let us know which one is the absolute smallest. Should triangle be the smallest? Should square be the smallest? Or should circle be the smallest? Criteria card C again takes a look at our 3 digits, triangle, square, and circle, but this time the Turing machine will add up the 3 digits and will let us know whether the sum total is an even quantity or an odd quantity. Criteria card D will take a look at our first 2 digits, triangle and square, add them together, and compare the sum to the number 6. So should the sum be less than 6? Should it be equal to 6? Or should the sum be greater than 6? Criteria card E, again, will take a look at the 3-digit solution, but this time the Turing machine will let us know a little bit about the structure of the 3-digit code. Should it have no repetitions, as in the example 125, or should it be a double number, as in the example 112, or is it a triple number, as in the example 222? And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by all of the 5 criteria cards we just described. And we're going to start off with an initial proposal of 314. So I think the first thing I'd like to test is criteria card C. Okay, so the Turing machine does not agree with my proposal. In criteria card C, we are adding up the 3 digits. So when I add up the 3 digits in the proposal, 3 plus 1 is 4, 4 plus 4 is 8. 8 is an even quantity, but since the Turing machine does not agree with it, the Turing machine is informing us that actually the sum of the 3 digits should be an odd quantity. So let's go ahead and type that up in our notes in section C. And we'll state that triangle plus square plus circle should be an odd quantity. So let's briefly discuss what are possible solutions knowing that the sum total is odd. Well, the obvious is that they all could be odd, since when you add up 3 odds, that sum total is odd. But you could also have a scenario where you could have 2 evens, and when you add those 2 evens, yeah, that sum total so far is even, but you add that 3rd digit that is odd, and then the sum total would remain odd. So 2 possibilities, either they're all odd or we've got 2 evens and a single odd. Next, let's go ahead and test criteria card E. Okay, so the Turing machine approves of the proposal. Notice that in 314, they are all unique, so no repetitions. So let's go ahead and type that up in our notes in section E, and we'll say that the solution has no repetitions. Well, that really did not resolve any questions we had about from criteria card C. So no repetitions, well, that works okay with 2 evens and an odd. Obviously, those 2 evens would have to be distinct, right? 2, 4, and some odd, possibly a 1. Or we could have an all odd solution. So I think I recall from previous puzzles that if you have this criteria card A, the number of ones, well, right now, since we know that there are no repetitions, we know you can't have 3, you can't have 2. So you either have 0 or 1. And I believe the thinking is, at least one strategy, is that if there is no 1, now mind you, I do have 1 in my proposal, but if you don't have a 1, then it would have to default to 2 evens and an odd. And the reason for that is that if there are no 1s, sure, you could have a 3 or a 5, but if you add 3 and 5 together, that's even. And because of no repetitions, you would be forced to pick an even, giving you a sum total that is even. So if there is no 1, you know you only have a single odd digit. You couldn't have 3, 5. That would produce an even sum. So that is a bit of a risk. Not just because I have a 1, that's okay. It is a 50-50. I'm just torn between picking criteria card A and D. And it could be, again, it is a 50-50. And criteria card D does have 3 different possibilities. We may have to retest it in the second round. So I think for that fact, I'm going to choose to test D. Okay, so it is not true that the sum, the sum of my 2 digits, triangle and square, add up to 4. 4 is less than 6. But the Turing Machine does not agree with that. So it's one of the other possibilities. Either the sum is equal to 6 or greater than 6. So let's go ahead and type that up in our notes in section D. And we'll state that triangle plus square is either equal to 6 or is greater than 6. Okay. So, well, and let's see, can we cross out anything? I don't think we can actually cross out anything because of the equal to 6. So that means 1 and 5 can be added together and other digits can give you a sum that's greater than 6. The only thing we can say, and just keep in mind that you just can't have 2 small values. So you're not going to have like a 1, 2 or a 2, 3 because those sums are less than 6. We just have to have recall that, yeah, we're going to have to pick 2 digits that'll give us a sum that's equal to or greater than 6. Okay, well, that does it for this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So just as a reminder, we did not test criteria card A, querying how many 1s. Again, it's a 50-50. Either there is a 1 or there isn't. We also didn't query which one could be the smallest of the digits. And of course, it's still outstanding what criteria card D might reveal. Is it the sum equal to 6 or greater than 6? So go piggybacking back on that idea of if there is no 1, that would mean you'd have 2 evens. And it could be that the sum is equal to 6. Well, the only way you could have a sum of 6 is if both those digits were of the same type, meaning either both odd or both even. And so I'm thinking that perhaps it may be the two evens, and then criteria card B would reveal which of the two between triangle and square is the smallest, so that you'd have a 2. If say circle were the smallest, and you'd have a sum of 6, again, you could have circle be the 1, and then triangle and square you'd have to deal with either 3 or 5. But well, at that point, then you wouldn't know which one would be the smallest. So maybe that's a point against an all odd solution. But if it were two evens in triangle and square, and triangle or square were the smallest, then you could see which of the two digits would be the 2, and then which one would be the 4. But that said, then circle would be odd, and if there are no ones, how would you pick between 3 and 5? Ooh, that's a good one. I don't think that would be possible. I don't think you could have a sum of 6 with two evens. Yeah, because if circle is the smallest with a 1, there's no guarantee. Well, I guess maybe, let's think about it. If circle were 1, if circle were 1, then it couldn't be 2, 4, or it couldn't be two evens, because you wouldn't know how to pick, how to choose which one would be the 2 and the 4. It'd be ambiguous. It could be either 2, 4 or 4, 2, and then the 1. So there's no way to distinguish that. And well, what about 1, 5? Maybe that could be it. Maybe there is a 1. Maybe it's going to be a 1, 5. That makes more sense. Between square and triangle, the smallest would be the 1, the other would be the 5, and then circle would default to 3. That seems to be the most plausible possibility. So yeah, let's go ahead and do that. So let's see, either it's going to be 1, 5, 3 or 1, 3, 5. Let's go ahead. I just like the ascending nature of it. Oh, I'm sorry. What am I saying? 3 has to be in circle. It'd either be 1, 5, 3 or 5. Yeah, 1, 5, 3 or 5, 1, 3. Actually, I think I like the 5, 1, 3. Let's give that a try. Okay, so just to double check, yes, the sum is all odd. I am choosing to see if the sum is equal to 6, and obviously 5, 1, 3 has no repetitions. Okay, well, let's give that a try, and let's see. If I pick a 1 again, that doesn't really tell me what the sum might be. If there is a 1, yeah, it's hard to say. So, yeah, let's go ahead. I'm just going to retest D. Okay, yeah, so the sum is equal to 6. Okay, so let's go ahead and cross out the OR. Okay, and let's see. So because the sum has to be 6 and there are no repetitions, I think we can at least cross out the 3's, which is kind of interesting, because that would lead to a pair of 3's. That's the only way to get a sum with a 3. So you couldn't have that. So it's either going to be 1, 5 or 2, 4, and then circle. I guess, Yeah, so since the only way you can get a sum of 6 is if they're of the same type, so either 1, 5 or 2, 4, that would mean that circle has to be odd. So we can actually cross out the 2 and the 4 in circle. Okay. Let's see, what else? Is there a 1? Yeah, and that'll tell us. Yeah, let's go ahead and test criteria card A. Yes, there is a single 1. The Turing Machine approves of a single 1 in the solution. So let's go ahead and type that up, and we shall say that the solution has a single 1. Okay, so we have a 1, and so obviously it's criteria card B that'll tell us where it goes. So let's say, again, let's play so that circle, if circle is 1, then you would have 2 and 4 in triangle and square, but neither of them, again, you wouldn't know how to pick which triangle should be the 2 or the 4, because 2, 4, and 4, 2 work just as well. So I don't think circle is going to be the smallest. So yeah, let's go ahead and test criteria card B. And so no, square is not the smallest. So I'm going to type it up as, I'm going to deduce that the smallest is actually triangle because of the reasons why circle can't be a 1. So let's go ahead, and I'm going to type it up as, I'm going to deduce that, again, triangle is the smallest. So triangle is the smallest. And so that would mean it would have to be the 1. And then square would have to be the 5. And then of course the circle would default to 3. And so let's double check everything. So again, I'm saying that it should be, oops, I think I crossed out too many. Yeah, triangle should be the smallest. I should not have crossed out the 5. So it looks like it should be 153. Okay, so let's just review. Yes, we need a single 1. We have it. I'm deducing that triangle is the smallest. Square can't be. The sum is odd. It is. That's 9. The sum of the first 2 is 6. That's correct from criteria card D. We got a check mark. And there are no repetitions. Okay, well, that does look to be our solution. So let's go verify. 153. 153. Okay, fantastic. Well, how do we do versus a Turing machine? Well, it is a 5 criteria card puzzle, but we did 6. We had to retest D, the sum of the first 2. So we did C, D, E in the first round. E was the only correct one. And then we did A, B, D in the second. And B was incorrect. So let's type that up, CDE. So CDE, E was correct. And then we did retest D, and we did get that sum of 6 to be true. I believe B was wrong, and A was correct. Okay, how do we do? Okay, so we beat the Turing Machine by 1 question. Okay, well, I don't think, let's see, had I tested criteria card A in the first round, we would have gotten a check, and that in itself would not have informed us of whether, I don't think it would have informed us whether we'd have 2 evens and an odd. I guess circle would have to be the odd. Well, if that were the case, it would, yeah, it would be that scenario that we did talk about. So, yeah, perhaps. Not sure, I'll be honest with you. But in any case, it's those kind of thought experiments that you sort of have to embark on, test out what works, especially if you want to minimize the number of tests. If that's your objective, then yeah. But I do believe that sometimes, I think if you just run the test and see where, what results from that, maybe there'd be less second guessing or less time spending what ifs. But it's fun nonetheless. Well, how about you? How did you solve it? Did you choose a different set of criteria cards? And did you notice anything interesting that you'd like to share? Please add those thoughts to the comments. If you liked the video, please do give it a thumbs up. And of course, don't forget to hit subscribe. Well, until next time, have a great one.